Namaskar. In 2025, Alipurduar division of NF Railway proudly celebrates a century of railway electrification, marking a milestone that has not only transformed the way India travels but also contributed significantly to the country's growth and development. From the first electric locomotive that began its journey in 1925 from Victoria Terminus to Kurla in Bombay to the high-speed electric trains of today, Indian railway electrification story is one of innovation, vision and progress. So let's take a look back at how it all began. In the early 20th century, Indian Railways was predominantly steam powered with trains running on coal. But the limitation of this technology, high operating costs, environmental concerns and fuel dependency made it clear that India needed a change. In 1925, the first section of Indian Railway was electrified between Howrah and Hooghly in West Bengal, marking a new chapter in Indian railway history. The electric traction was seen as more efficient and environmental friendly, setting the stage for rapid transformation. As of 2025, over 75% of Indian Railway's total track length is electrified, and the goal is to make it fully electrified by 2030. India is world's fourth largest railway network, but in terms of railway electrification, it is only second after China. This will not only reduce carbon emissions but also make the entire railway network more energy efficient and sustainable. Electrification has allowed Indian Railways to offer more faster and more reliable services. With electrical trains, we have been able to cut travel time on major routine, enhance capacity and provide smoother journeys for millions of passengers daily. But this progress has not come easy. It has been a result of decades of dedication from engineers, workers and visionaries who have faced the immense challenge of technology and infrastructure. The commitment to electrifying the tracks has not only changed the face of rail travel in India but has also empowered local communities, provide thousands of jobs and strengthened India's energy sector. Now let's understand the basic science and engineering behind this railway electrification and how Indian Railways run. Indian Railways uses an electric traction system where electric trains are powered by electricity supplied via overhead lines, in short from OHE. In some cases, a third rail running along the track. The trains themselves are equipped with pantographs or collectors that make contact with the overhead wires or third rail to draw electricity. Basically, there are two main types of electric supply systems used by Indian Railways. In early days of railway electrification in places like Mumbai and Kolkata, DC system has been largely used, but which has been phased out in favor of alternating current. The most commonly used system today used in India is 25 kV alternating current running by 50 Hz frequency. Most of the electrified tracks use the overhead catenary system. This means that the electricity is carried through wires, copper wires, that are suspended above the train's route. The pantograph on top of the train collects the power from these wires. These wires are connected to power stations that supply electricity to the trains. These substations step down the high voltage electricity from the grid to a lower voltage suitable for the trains. Each substation is responsible for powering a section of the railway network. A railway traction substation has lot of equipments like mainly the power transformer which step downs a 132 kV high electric current to 25 kV electric current, which is suitable for Indian Railways to run smoothly. The transformers along with other equipments like lightning arrestor, current transformer, potential transformer, these equipments help to run the substation smoothly. So basically in catenary system, the copper wires are supported by cantilever assemblies which are further supported by masts. Few components of cantilever assemblies are bracket tubes, steady tubes, register arm. In between two copper wires, copper fittings called droppers are attached of variable length, which is further fixed by dropper clips. Section insulator allows isolation of specific section to allow maintenance of overhead equipments without power disruption of whole section. In case of any fault in OHE, it prevents the issue from spreading to other parts of the system, thus helping fast fault identification and repairing. So does a PTFE or a neutral section zone that isolates two different phases coming from two different substations. Now you might wonder that what may happen when the contact wire short ends. It might hit with the mast, But to overcome this problem, overlaps are made and contact wire shorts are fixed with ATD or auto tensioning devices, which prevent sag and maintenance tension variation without the effect of temperature variation. Electricity collected by pantograph is utilized by electric multiple units. OHE acts as positive and ground as negative, thus creating a suitable potential difference which runs the locomotive smoothly. And in this way, Indian Railways run. NFR is achieving its goal of railway electrification at a very faster rate, and soon it will target its goal of 100% electrification. But this achievement has only been possible because of hard work and dedication of railway engineers and staffs who have demonstrated exceptional dedication and commitment. Their hard work, resilience and long hours of effort in challenging conditions have been crucial in driving this ambitious project forward. This is a proud movement for all to cheer and celebrate this big achievement of 100 years of railway electrification. Hope you enjoyed this video. Jai Hind, Vande Mataram.